All right, welcome back. Let's do one more example here. So now what I'm going to do is let's look at factoring the top. Let's see if we can put this in factored form. Okay. So one of the things that I want to mention that's mentioned in the textbook, and I don't think I mentioned it prior to this video, but remember, part of the definition is we want this to be in lowest terms, right? So we don't want any common factors. Remember, in the definition, it said no common factors other than 1 between the numerator and the denominator. So let's factor this. Okay, so let's factor the numerator just to see, right? Want to make sure it's in lowest form. So let's see here. So we've got, so multiply these together, we get 8. So 2 factors of 8 that add up to 9 is 1 and 8. So we could do 2x squared plus 1x plus 8x plus 4. Okay? So now let's group these together. And so now I'm going to factor out an x, which is going to be, give me x times 2x plus 1, plus, now I'm going to factor out a 4 here, which is going to give me 2x plus 1, and so now I have a common factor. So now I'm going to factor out the 2x plus 1, which is going to leave me with x plus 4, and those are my common factors. So now I'm going to write this as 2x plus 1 and x plus 4 and x plus 3. Okay, so no common factors. Good. Okay, good. So now let's see about graphing this thing. So let's go through the process. So again, we want to know what the y-intercept is, right? So y-intercept, again, we're looking at f of 0 or h of 0. So we're just going to plug in 0. And so all we're going to get is 1, 4, and 3. So we're going to get 4 divided by 3. So we know our y-intercept is going to be 0, 4/3. Okay, what about x-intercepts? Now this is where we want to set h of x equal to 0, which means we're looking at just the numerator. So now that it's in factored form, it's easy for us to solve when the numerator is equal to 0. So that's going to give us 2 x-intercepts. So the first x-intercept is going to be negative 1/2, 0. And the other x-intercept is going to be what? It's going to be negative 4, 0. Okay. Now vertical asymptotes, we can see that there's going to be a vertical asymptote at x equals negative 3. Horizontal asymptote, we can look over here, back to here, we could see that the degree of the numerator is exactly 1 more than the degree of the denominator, which means we do not have a horizontal asymptote, but we do have an oblique asymptote. And so now what we're going to do is we're going to divide, and in this case I'm going to use synthetic division to find the quotient, right? So in this case here it's negative 3. Remember, it's always x minus c. So negative 3 is my c value. So if I use negative 3, now I'm going to use the coefficients here, 2, 9, and 4. There's no missing terms, so it's just going to be 2, 9, and 4. And so now I'm going to use synthetic division, and all I need is the quotient. That's all I'm looking for here. So in this case it's going to be 2, negative 6, 3, negative 9, negative 5. So there's my remainder. And so now the resulting quotient is going to be what? It's going to be 2x plus 3. And so that is the equation of my slant or oblique asymptote. Okay? So I'm going to put slant or SA. I'll put SA for slant. Or OA for oblique. I'll use OA. Okay. So OA for oblique asymptote is going to be y equals 2x plus 3, right? Okay, what else? What else can I get? Okay. Well, we know it won't cross the oblique asymptote. We know it won't cross the vertical asymptote. Okay? And since we have an oblique asymptote, we know that there are no horizontal asymptotes. Now, what about symmetry? Yeah, in this case, it's not going to be easy to put symmetry together. It's not even, and it's definitely not odd. So it's not symmetric about the origin, and it's not symmetric with respect to the y-axis. So let's plot some points. Okay, so let's see what we can get here. Oops, I should have left that factored. What was that? There was 2x plus 1 and x yeah, that's right. There we go. Okay. So let's see. What do we get? Okay, let's plot this sucker. Just do the best we can. All right. Okay, so let's plot the intercepts. So the y-intercept is at 0, 4 1/3, or 4/3 I mean. So that's going to be 1 1/3. So let's say about right there. And then we have negative 1/2, 0. So negative 1/2, 0 is about right there. And then negative 4, 0 is right there. Okay, so we've got those intercepts. Now we've got a vertical asymptote at negative 3. So let's draw this like so. We've got our oblique asymptote at y equals 2x plus 3. So 2x plus 3, so in this case it has a y-intercept of 3. So it's going to cross there. And it has a slope of 2. So it's going to go up 2 over 1. So let me just plot a couple of points here. So there, and that's going to go down to right. Oops, hold on. Right there. Okay, and then it's going to go to negative 3 here. Right about there. Okay, so now notice it's going to go let me do a better job. Hold on. Like so. So there's the other asymptote, the oblique asymptote. All right, so now here's the thing. We've got this area here that we have to test, and then we've got this area here, right? What's going on in between these two asymptotes? What's going on in this area here, right? So right away, one thing we notice is, notice how the intercepts, the x and y intercept, this x-intercept is over here with this. So we know the graph is going to be on this side of the slant, okay? Now we don't know what's going on in this side. Is it over here or is it down here? Don't know yet. We'll have to test a point here to see where it ends up at, okay? And then we're going to have to test a point over here in between this intercept and the asymptote here, the vertical asymptote, to see where it ends up. Does it end up here? Okay, or does it end up, well actually no, we already know, never mind, hold on a second. No, because on this side here, the intercept is here. So we know we're on this side of the, both of these, okay? So I don't, yeah. So it looks like we're going to end up on this side here, and then we're probably going to end up inside here, and then on this side. Okay, but let's test some points, okay? So first, let's test -5, right? So at -5, where are we? -5 makes us, this is going to be negative. This is going to be negative, so this is, the numerator is going to be positive, so it's going to be negative. Is that right? Negative, negative, negative. Yes. So we're going to end up with negative. So this is going to be below the x-axis. Okay, so let's do end behavior. So as x gets, okay, so here. So we know here, let's see. So this, so we know this goes like this, right? Okay, so there's that line. So we know it's here. Oh, you know what? So we know at -5 it's going to be negative. So it's going to be below the x-axis. Let's -6. So -6 is still going to be negative. So it's going to stay negative here. What about -2? Where does it end up here at -2? So -2 is going to give us negative 3 here, positive 2 here, so negative 2, so negative 4, negative 3, negative 3 times 2 is negative 6, and this is going to give us a positive 1. So it's going to give us negative 6, right? So negative 2, so negative 4, that gives us negative 3 here, right? So that'll be a negative 3. This will be a positive 2, and this will give us 1, which will give us negative 6. So at negative 2, we're going to be at negative 6, which is right down here. All right, so we're going to be in that area. And as we get closer to negative 3, right, as we get closer to negative 3 here, from the right, so if we put in, so if we put in negative 3 here, right, this is going to be negative, this is going to be positive, and if we're coming from the right, this is going to be positive. So this whole thing is negative, but it's getting closer and closer. This is getting closer and closer to 0. This is getting closer and closer to negative 5. This is getting closer and closer to 1. So this is getting closer to negative 5, but this is getting closer to 0, but the whole thing is staying negative. So this is going to negative infinity. But on this side, as x is getting large, it's getting closer and closer to this line. So on this side, it's doing something like this. So let me do this. It's doing something like that. Now, so there's nothing going on in here, right? Now, what about on this side? Well, we kind of already talked about it, but let's look at this. When it's negative 5, where is this going? So actually, let's look at this when we go towards negative 3. From the left. We didn't talk about the left. So if I'm looking at negative 3 from the left, right, as I get closer to negative 3, what's going on here? Again, if I put in negative 3 here, no issue. So this is going to negative 5, and this is going to 1. So this whole thing is going to negative 5. But the bottom is going towards 0, but since we're on the left side, that means this is negative. So this is positive, but it's getting, since this is going to 0, but the whole thing is positive, it's going to positive infinity. So this is doing this. Now, it crosses here, but at negative 5, what's going on? At negative 5, we have what? We have negative 10, so negative 9. Negative 9 times negative 1, so that's positive 5. Positive 5 divided by negative 2, so that's negative 5/2, right? So let's do this. So if we plug in negative 5, this is negative 9, right? Let me make sure we did that right. So negative 5, So that's going to be negative 9. Here, negative 5. Right? And plus 4 is going to be what? Negative 1. And then, so this is going to be 9, right? So this product is 9. And then, of course, negative 5 here in the bottom, negative 5 plus 3 is negative 2. So it's going to be negative 9 halves, which is 4.5, negative 4.5. So here, it's going to be negative 5. It's going to be down here at negative 4.5. So look at it, it's doing the same thing. So here, it's doing this. Oops, I didn't do that quite right. So it's doing something like that. All right. Cool. That's it.